Okay, so now we're going to talk about polyatomic ions. Okay, so poly means more than two, so mono is one, bi is two, poly is more than that. So polyatomic just means that we're going to have more than, two ions in a formula. So an example of this would be sodium chloride, and this is NaClO2, and it's used in the processing of bleaching of pulp from wood fibers and recycled cardboard. So what we're going to learn now is how to write the name and the formula of an ionic compound that contains more than two. Okay, so a polyatomic ion. So same principles, we just have to build on that a little bit more. So there are a group of atoms with an overall charge, and it's often consists of a nonmetal such as phosphorus, sulfur, carbon, or nitrogen, and oxygen. And usually they have a -1, -2, or -3 charge. And if they have a negative charge, except for NH4 plus, which is ammonium, this has a positive charge. So there's exceptions to rules. So this one is one you'll just have to kind of remember. So many products contain polyatomic ions, which are groups of ions that have an ionic charge. Okay. So here's a fun little table for you again, with the names and formulas of some common polyatomic ions. And so again, this is another one that you might want to print off and have by you for a while to be able to do these calculations. And the common ones are highlighted. So we have nitrate, chlorate, carbonate, sulfate, phosphate. So you'll notice that the other ones were ending in "ide," and these ones are now ending in "ate." And so that's another kind of fun thing that you can use to try to discern what we're actually asking you. And so look at this, names of some of the common polyatomic ions that are going to end in "ate." Again, sulfate, phosphate, nitrate. And when a related ion has one fewer oxygens, then its name is "ite." And so if we look at sulfate versus sulfite, sulfate has 4 oxygens, where sulfite only has the 3, because again, it has one fewer oxygen. Phosphate has 4 oxygens, phosphite has 3. Nitrate has 3, nitrite has 2. So again, as we continue practicing, these will start to, roll off your tongue and get a little bit more familiar. So exceptions to these rules, because of course there's always going to be exceptions, are cyanide and hydroxide. So also we can add a hydrogen to the polyatomic ion, and this again, since we have a positive charge, is going to add a +1 to its charge. So if we have the carbonate here, right, and we're going to add a hydrogen, then that ends up being a bicarbonate or a hydrogen carbonate. Same name for different name for same chemical. Same with a sulfate. Okay, add a hydrogen, and that ends up being bisulfate or hydrogen sulfate. So just a couple nuances in how we can do these. Okay. Halogens form 4 polyatomic ions with hydrogen, and each of these have a -1 charge. So ClO4 is perchlorate. ClO3 is going to be chlorate. ClO2 is chlorite. ClO, just the one, is hypochlorite. Okay. How do we use this to write formulas? Okay. When writing formulas for ionic compounds containing polyatomic ions, we use the same rules of charge balance as we use for those simple ionic compounds. So let's consider the formula for magnesium nitrate. Okay, so our magnesium has a +2, okay, and our nitrate has the -3, and so you end up having to do the balance, right? Of magnesium is +2, and then the nitrate has a -1, so we need 2 of those to equal it out. So it ends up being magnesium 2 with the NO3. And the parentheses here, this just means that whatever is in the parentheses is repeated that amount of times. So you could write it out NO3, NO3, but that gets messy and not as clear. and clean, so we write it as NO3 2. So again, the parentheses are placed around the polyatomic ion, and the subscript is placed outside the parentheses. So it's just how many times it's going to be repeating. Okay, so our handy dandy little guide. What we're going to do is identify the cation and anion, balance the charges, write the formula, cation first, using subscript for the charge balance. Okay, so if we're going to write a formula for aluminum bicarbonate, okay, what are we going to do? Write down aluminum, refer to your chart. Aluminum has a +3 charge, and then the HO3 or HCO3 has a negative charge, and since just a single one, and since we have to balance this out, we have one positive charge, which means we're going to have 3 negative charges to end up having it equalize. And so then that ends up becoming aluminum and then 3 of the bicarbs so that it all equals out. Okay? So let us practice. So pause me and let's write the formula for sodium phosphate. Okay, so pause me and then come back. So sodium has a +1 and the phosphate is PO4 -3, so it has a -3 charge. And so since this has a -3 charge, we're going to need 3 of the sodiums to equalize it out. Okay, so then that ends up being Na3 PO4. And so again, what we're looking for is an equalized compound. Okay. So naming compounds with polyatomic ions. When naming an ionic compound that contains the multiple polyatomic ions, first we're going to write the positive ion, which is usually a metal, and then we're going to name the polyatomic ion second. And so recognizing the polyatomic ions in a chemical formula helps to name the compound correctly. So as with other ionic compounds, no prefixes are used. And so we have sodium, and then the SO4 is sulfate. We have iron, the PO4 is phosphate. We have aluminum, and then the CO3 is carbonate. And then again, this 3 and after the parentheses is to equalize out the aluminum charges. Okay, so here's another great table. This is where it'd be great to have a book. Hopefully one day I'll get it. I might actually just end up buying it because it's kind of getting ridiculous to not have a book. Anyway, so here are some common compounds with polyatomic ions. So we have barium sulfate, and what is it used for? Contrast medium for X-ray dyes. Tastes like chalk. It's gross. Make sure to drink lots and lots of water. Calcium carbonate, calcium phosphate, calcium sulfate, silver nitrate. You can read through those. Okay. So let us do a study check. Okay, so let's select the correct formula for each compound. Aluminum nitrate, copper nitrate, iron hydroxide, and tin hydroxide. So pause me, do it, and come back. So aluminum nitrate is AlNO3 3. Copper 2 nitrate is CuNO3 2. The iron hydroxide is iron OH3. Okay. And then the tin is the tin hydroxide repeated 4 times. All right.